Hello and welcome. I'm so happy to see you all virtually and in human form. We are truly operating in cyborg time, so we're really excited about this talk tonight that will really fully embrace all of those things. I'm realizing I'm sort of out of frame. So hello everyone, my name is Beth. I'm the executive director here at GenSpace. I am a scientist by training, but I've been working in education and community engagement in science and STEM education kind of programs for a long time. You all are the reason that I love this work. I love the curiosity and the creativity and the wonder that you bring to science as artists, designers, architects, engineers, curious humans of all sorts. So I'm really, really grateful for each and every one of you to be here tonight with us, to explore science together, to learn some cool things, to talk about some cool things. For anyone who's new, yes, that's right. Yes, we all learn from each other, and that's a big part of the ecosystem of GenSpace, is that it's fundamentally about mutual learning. We all know that we come to the table with some knowledge, some lived expertise, some special skill that we want to be able to exchange with each other, learn from each other, learn with each other. So you learning is me learning. So I'm really grateful to be here.
Symbiogenesis.
Yes, absolutely, absolutely. For anyone who's new to the lab, oh, thank you. GenSpace is a community science lab. We're an open access science space. We have a suite of programs and experiences for people to learn science in a hands-on way. That's kind of fundamentally what sets us apart from other organizations or other learning experiences. So we have programs like classes and workshops. So if you all are interested in learning how to do CRISPR or make your own bioplastics or grow your own mushroom lamp or experiment with kombucha and mycelium, we have a place where you could come and learn how to do those skills and be in community with other learners and other creators. We have a membership program, which is for a monthly fee. You're able to come and use our lab 24/7. It's your space to be creative and make what you will make, as long as it fits within our safety guidelines. And again, we provide a little bit of training and a little bit of support, and we provide a lot of consumables and other materials for you to carry on your projects. We also have youth internship programs and outreach that we do out in the community and the neighborhood. Again, trying to bring science out of traditional academic and industry spaces and into the hands of the people who are actually going to use it and make something really interesting with it. So that's kind of our ethos and our ethic, and we're just really grateful tonight to have Giovanni here with us. So let me just double check my notes. Yes. So I met Giovanni about, what, maybe 2 months ago, 3 months ago? Yeah.
No, even 2 months, yeah. Probably. But yeah.
He came to take a bioplastics class with us, which you'll hear more about tonight. But I was really excited to learn more about his path and his history. Giovanni is from Milan, Italy, is that right?
No, from Verona, Italy, but yeah, I was living in Milan.
Living in Milan, okay, great. And he's had so many wonderful, amazing experiences, residencies in so many different places. Just recently finished up a residency with Elisa at NARS, is that, yeah? Yeah, and so if you all don't know NARS yet, please make sure that you introduce yourself to Elisa and hear more about the amazing residencies that they provide and the artists that they support. And then, let's see, anything else that I should make sure I say about you? You ready to go?
Yeah.
All right, I'm gonna turn it over to Giovanni and let's have some fun tonight. The way that this is gonna go, he'll speak for a bit, we'll have a bit of time for Q&A, and then for the end of the evening, we'll just have some time to mix and mingle. If you'd like to come and see more of the lab or chat. Oh, I forgot to introduce our team, sorry. Vanessa, do you wanna quickly wave and say hello?
Hello, I'm Vanessa. I'm the Development and Communications Manager. So I handle all of the fundraising, storytelling, also social media and press and all that.
A million amazing things. Thank you, Vanessa. And then we also have Joanna. Joanna's one of our incredible volunteers. You want to tell them quickly about you?
Hi, I'm Giovanni Chiamenti. Albert Einstein, and I do science for life. So,
Yeah.
but I'm always away, so people want to learn about science outside from the outside field. And yeah, just talking sometimes to non-nerds is also fun. So
yeah. Nerds in different ways. Yes, thank you all so much again for being here. So excited. I'm going to do a switcheroo on the computer, and then it'll be your turn. Let's do, okay. That's great technology. Good. We should be good. Okay, I'm going to try to shrink this down a little bit. to keep it out of your way. Is that okay? Can you still see mostly what you need?
Yeah, I'm gonna switch. No.
Quick, yeah, quick.
How do you want me to switch slide?
Yeah, there it goes. So now you can.
Will. Yeah.
Great.
Okay.
Wonderful.
Great.
Yeah, thank
While
you.
we're waiting, I just want to confirm for our new people, if you're okay with photos, if you're not, please let me know so I can make sure.
Great.
Yeah.
So thank you, Beth, for inviting me and believing in my practice because yeah, we had just a moment. I had just a moment to come divided with you, and yeah, and thanks to all of you guys for being here and listen to me. I hope you're gonna get something. I hope I'm gonna be clear enough for you to understand something about my practice. So the project that I'm gonna talk to you about is interspecies mutations, and it's the research that I started during my residency at NARS Foundation in past 3 months, and it wants to create this new archive of species that could develop on our planet and on in our oceans, because I'm talking about, I will talk about creatures in deep sea, and in a not so distant future, as a result of hybridization between animal and plant world, and but also of their capacities to integrate the microplastic we are producing into their tissues and into their biocells. So the project relates, yeah, it's the other PowerPoint, but yeah, I mean, it's okay. The project is related to deep sea because most of the people and the public opinion is talking about plastic pollution, but in surface, not going in depth. And we know that there's this giant Pacific garbage patch in the middle of the oceans. There are these islands of plastics that are floating around in our oceans, but we don't know anything. But most of the people don't know anything about microplastic pollution in the depths of the seas. So this is why I want to talk about this environment that we have access to only through machines and robots, but still we've been able to pollute that environment. So this series started derives from a series of ceramics work that I've done during the past few years, and which attempt was that of outlining a new organic glossary. Let me explain. An archaeology of a not so far-fetched future in which animal and plants will hybridize to survive to an increasingly polluted environment. And all the titles of these works were in Latin, so they had scientific nomenclature, and yeah, putting together names coming from existed or existing creatures, assembled with adjectives coming from a utopian imaginarium that in this case was mine. But still, I was giving them a sort of a realistic, a sort of reality. Because, yeah, this project has started from a real hybrid that scientists have studied in the past 20 years that is called Elysia chlorotica, and it's marine gastropod that is able to perform chlorophyll photosynthesis by integrating the chloroplasts contained in the algae it feeds on. So the process of this animal is like this. The image that I'm showing you is was collected in a laboratory, so it's a culturing of Elisa chlorotica in a culture of Elisa chlorotica in a laboratory, and it passed from being grayish brown till when it starts to hit this algae. After 5 days, it takes this color that is fluorescent green, and it's just amazing how they don't know, they still don't know how it's able to integrate just part of these chloroplasts, and then the rest of them are released to produce the photosynthesis. So starting from that, I decided to create my first piece. This one was the first piece that I made from the first series, and it's called Infatuate chlorotica, assembling the family of Nymphaceae, that is the family of Nymphae, with the adjective chlorotica coming from Elysia chlorotica. All the series was made in Western Raku because it's the only technique that you can use with black cupric oxide and silver nitrate, also, and other colors. But these two metals, you can, the color is gonna change in the next few months. If it depends how much light, how much sunlight they're gonna take. So they are gonna pass from being super metallic till being matte and pretty grayish. So it's something that relate them to natural phenomena and natural mutation inside the animals and plants. These two projects that I'm talking about are related to the concept of symbiogenesis. Symbiogenesis is the capacity of a creature to coexist and co-create with the other. We had to understand that everyone and every little organism has a role in this planet, and we have to respect it to make a better planet. I know it seems like a fucking advertisement, but it's reality. I mean, we have to respect each other, and you find out this text that is taken from one of my videos and it's coming from 2020. And so it was saying, to live with on our planet, we do not need antagonism, but rather attunement. No tunnel vision, but rather multifocality. No alienation, but rather symbiosis. And there is no longer distinction between guests and parasites. And this last phrase is really, I think is really, is pretty right. And it got me to this species that are the Siphonophores, and the Siphonophores are a multi-organism colony. So they are divided in polyps and zooids with specialized function, but each zooid cannot live without the others. So they are interrelated, and they are, and to survive, they have to coexist and cohabit in the same organism. So this one is, in particular, is called Portuguese Waro Manowar, and yeah, in Italian is Caravella Portuguese, and it's one of the well known. And this other one, I cannot remember the name, but it's also another Siphonophorus. So during my residency, and thanks to GenSpace, I started to experiment with bioplastics. And with bioplastic, in this case, I mean totally biodegradable plastics. So I started to use, in this case, the one you see is made with capacaraginen, that is polysaccharide coming from a family of red algae in the Atlantic, but also in Pacific, in few places around the globe. And yeah, I started to experiment with it. And the last thing, yeah, one of the interesting things, it has emerged as a promising candidate in tissue engineering, but also in regenerative medicine applications. So these are few of the uses that are made of it. But the last thing I found out is, yeah, the last thing that I wanted to see is its capacity of, yeah, I'm going to show to the people that are, yeah, on Zoom, that its capacity of biodegrade in water. So when you pour them for the second time, when you get the right dry material and you re-pour in water, and it just expand and return to the original form, to its original form, and its to its original gelatin appearance, gelatin form. So it's pretty interesting also to see that it cannot absorb water, so it's going to stay at the part that is melting is just the one that is in the water, and the other part, it just stays dry. I can understand why, but it means that this algae and this polymer has something that is hydrophobic at one point. The other material that I used, that I'm still using, is Chitosan, and Chitosan is a polymer and a polysaccharide that compose the shells of the crustacean and the mollusks, but also is contained in different types of fungi and other species. The thing about Chitosan is that the curiosity about Chitosan and chitin is that if there are studies that says that used in powder or in flakes for it can reduce oil spills in seawater. So it's pretty interesting how natural material could find also a solution for oil spills in seawater. And the other thing about these works that I'm doing with these bioplastics is that I am using them as sort of dried skins. And shells of these embryos and microorganisms that could be at one point totally made of plastic. So the thing that you're seeing inside of it, in the middle of it, is made with thermoplastic pellets. And these thermoplastic pellets are curious because you can pour them in boiling water and then you can model them. So they had to do also with water. And yeah, it's interesting how synthetic materials are made to mime natural aspects and natural phenomena. Yeah, now you can see another example of it. And the other thing is that with the same amount of time inside water, it still has more structure than the other one, than the capacaraginen. So it's not melting and it's not even jelly. It has, yeah, something that is more related probably to the fact that it is composing shells. The other materials that I'm using for this project are totally synthetic, as the thermoplastic pellet that I showed you. So in this case, you can see a sheet of epoxy resin assembled with a piece of a bioplastic made with kappa carrageenan. But I wanted to have these three types, three different materials, so the ceramic, the bioplastic, and the synthetic material, because they have to do with different aspects of the topic that I'm treating. So in this case, synthetic materials are just represented the consequences of pollution in nature, and also they embody the evolution of the species that we are already seeing. And all this project is linked to the reality, despite having a strong sci-fi and dystopian component, because as you could see, it's so related to microbiology and geology, and the only thing that is attached to a dystopian and has a sci-fi component are the forms that I am adopting, because they are coming from my imaginarium. They are not related at all to a real existing creature coming from the deep sea. Also, if I took if I got my research on that environment. The other thing that the other interesting thing that I found out is this other bacterium that I'm going to talk you about. That is this Ideonella sakaiensis, and it's a bacteria. It's a bacterium that has been studied by scientists, and it can actually break down and consuming plastic. In this particular case, PET, so the most common plastic we got in the world. And it's strange how the form of this bacteria resemble this material perfectly. And I made the species before knowing of this bacteria. Another interesting creature that I found out is this giant larvacean that helped remove large amount of carbon dioxide from atmosphere into ocean depths, in addition to transporting microplastic through its outer filter, because it has two filters. The one you can see, this one is the outer filter, and it uses it as it actually don't use it as a filter to ingest a rest of animal that it can actually eat, but it just is made of mucus, and it just trap everything it can find during its path from 200 meters under sea level till the seafloor. So, and when this filter is going to be clogged with food, it's just released it and just expel it. And this filter is going down. And all the things that are trapped are full of carbon. And so it actually can reduce carbon dioxide from the from atmosphere in this way. It's pretty strange. Yeah, as all the creatures probably that you saw it. But yeah, this one was the installation I made at NARS. As you can see, it was a sort of archipelago. But the solo show that I'm gonna have in Italy is gonna be in a place that was a collector from a collector of water of a medieval fountain. So this place was full of water at the beginning of its life, and I'm gonna recreate a marine environment in it. And so the space is gonna be full of this black sand, and there's gonna be also a pool to show the capacity of the bioplastic to biodegrade during a month. Yeah, and these are two other examples. The one on the left is made with Chitosan, but this one was the first attempt to create a form, and it was the only one that I tried to cast actually, but I couldn't, because the material, it tends to shrink, and when it dries, it creates its forms. And I don't like the thing about using cast and molds. It's not for me. I like these creatures and this to be free and to just take their home form. I don't have to be the judge or to be the owner or the creator of these forms. In the right part, you can see another example of the thermoplastic pellet also used in another way. So the last thing we'll talk to you about is these Plasticglomerates. And Plasticglomerates is a term that was proposed by Patricia Corcoran, Charles J. Moore, and Kelly Jasvak for a stone that contains mixture of sedimentary grains and other natural debris that is held together with iron and molten plastic. So they found out in Hawaii the first time, and they have been studied and they have been presented also in quite big shows around in the US, but also in Europe. We had this triennial that was called Broken Nature, and that showed this process and these agglomerates that can actually form because of the melting lava that is going down a volcano. In this case, the first time was an isle in Hawaii, and when lava arrives near water and it finds plastic or other debris, it actually can conglomerate also all these things together. So the last part is dedicated and is going to be presented by this friend of mine that is here present and is a curator of artist books in particular, and we can welcome Oscar Salguero to talk about his archive. Yeah, you can yeah, get here.
And the people online.
Yeah, they can see you.
Thank you. Thank you, everyone. Thanks, Giovanni. I also want to thank Elisa for connecting me to Giovanni. Obviously, we have very similar interests, interspecies. So Interspecies Library is an archive of artist books that I've been developing. Is it okay if I? So it's an archive of artist books that I've been collecting in the last few years. And basically what I'm looking for is, I'm noticing this trend of several artists in the last few years really concerned and interested in the topic of our relationship with other species and how that's affecting their works. And the other thing that I'm noticing is that many of them are trying to present those ideas, those really experimental or alternative fictions through books, because books being medium that a lot of people understand and are really familiar with. And so this is what you're seeing here is the first public experiment that I did at the Center for Book Arts. That was called Interspecies Futures and happened last year during the spring. So yeah, new proposals for coexistence with other species and non-human intelligences. I tend to look for more experimental side of things. The one feature here is called the Tiger Penis Project by Huang Yiku.
Yeah, super cool.
Yeah,
It's just amazing.
Juan Yiku used to be a dentist and moved to the Netherlands and started dabbling with bioarts. And so this is a conceptual idea where basically instead of killing exotic animals to use their parts, in this case, the penis of a tiger for virility, and putting in danger a whole species, what if we start developing bioprinting these organs or mixing different organs, and then so you avoid all of that. So in this case, like what I like about this book is that you can also complement the narrative with one of the objects, and what Giovanni is doing basically is very much on that side of things, developing physical materialization of the concept. And yes, I look for a lot of like alternative realities and things that offer solutions or maybe imaginative futures with other species. And right now I have the collection is growing and growing, and I eventually would love for it to be public in some way, or just to have it accessible to artists, researchers, or anyone in general. I think these are documents that need to be seen and need to be.
And you're also working on a website.
Yes, a website. So right now I don't have a specific link, but I own already like interspecieslibrary.com. So yeah, it's gonna come up. Interspecieslibrary.com. We'll have all of these archive of books. So what I want to do is start by making an online archive where everyone can just access it and see all the collection, how all these artists their ideas sort of communicate to each other. It'll be a platform, so where maybe we can have recordings of the artists presenting their ideas, look through the entire book, really interesting things like that. And so the reason why we are connecting is because Giovanni and I would love to do a collaboration.
We are going to have a publication. I'm going to have a publication at the end of this research, and thanks to the grant that I took from Ministry of Culture in Italy. So we are gonna do a publication together, and together also with Jonathan Goodman, that is an art writer based in New York, and Kyle Frischkorn, that is also a volunteer here and it's part of GenSpace. And so the thing about this publication is the fact of sensibilizing people on this topic, because as I said, most of the time that we are talking about plastic pollution, we are not talking about microplastic in the depths of the oceans, where we are talking about the thing we can see and the thing we have on the fucking planet, on the earth. And also the Great Pacific Garbage Patch is not so common for most of the people. So we have to sensibilize these topics and this theme, because it has to be known now. There's no more time to wait. That's it.
Yeah.
It was really harsh, the last part. I don't know. I'm gonna have another beer.
Yeah, so we're ready to open it up for questions. We'd love to hear from you all, and ask questions if you would like to identify yourself.